Hello, Algebra Scholars. Today we are going to be covering the first few pages of our Flipbook on polynomials. You'll notice that I've written my name on this first page, and you should have cut across this dashed line already, and this should flip up really nicely, kind of like my answer key here. And you should have all these tabs laid out like so. So if you've accomplished that, please continue on this video. If you have not, go ahead and pause and get your book in order. But we are off. The first thing we need to do is get some vocabulary down. So I've got several terms that are probably going to be really new to you. I want you to be able to understand what these words are as we move through, and I want to be able to use them without you getting confused. So I want to give you some definitions right now, some examples of what each of these things are. So while we're learning and I'm teaching you moving forward, these will just be part of your vocabulary. So we're going to start with the word monomial. A monomial is a number, variable, or product of a number and one or more variables. A monomial is a number, variable, or product of a number and one or more variables. Okay, so a monomial is like something that we've been calling a term so far this year. It's something, either a number or variable all by itself, or something that's attached with multiplication, usually just kind of stuck together like we see a coefficient and a variable. So here's some examples. Here's a number. We call this a monomial. Here is a variable. We call this, when it's all by itself, a monomial. Here is 2x. We call this a monomial. Here is 7xy. We call this a monomial, okay? Notice what is absent. It does not have an addition or a subtraction sign separating any of these. If there was addition or subtraction sign, then we would not have just a monomial. Okay, next definition. Degree of a monomial. Degree of a monomial is the sum of the exponents of all its variables. Is the sum of the exponents of all its variables. For instance, 5. This monomial has a degree of 0 because there is no variable. So there are no exponents on a variable. Next example. X has a degree of 1. Notice there is an exponent of 1 right here. Another example of a degree of 1 is 2x. It doesn't matter that there's a number in front of this. This is still a degree 1 variable. Let's do a couple more examples. 7xy. We have a degree 2 monomial. Okay, we're going to see lots of examples here. Now, if this stuff feels like foreign language to you right now, that's okay, it is. I mean, you've never heard this stuff before. This is brand new for you. It's okay that it doesn't make sense right now. We're just getting something that we can go back to, and we can start understanding this. But notice this is degree 2 because there's an exponent of 1 here. There's an exponent of 1 here. If I take the sum of those exponents, I get a 2. So think x squared, that's a degree 2. X squared y, that's a degree 3 because there's an exponent of 2 on that x, plus an exponent of 1 on that y, etc. Okay, now this word polynomial, which is what this whole flipbook is defined by. A polynomial is a monomial or the sum of monomials. But so any monomial is also a polynomial, but poly means many, right? So many monomials. Usually when we think of a polynomial, we're thinking of the sum of a bunch of different monomials, or the sum of a bunch of different terms. So if we just like put addition, subtraction signs between all of these, we're making a polynomial. But it's also true that each of these individually is also defined as a polynomial. So, a quick example here is 2x squared plus 5x. The sum of two monomials is a polynomial. Okay, next page, and you'll notice I haven't cut these out because I thought it'd be easier to do this video without them, but you should have cut along this dashed line, and you should see the next thing below this. Okay, so standard form is our next thing that we are looking at. Standard form, I mean, this is really simple, and we've used this word standard form for a lot of different things, and it kind of ends up meaning similar things as we go along. But when we're looking at polynomials, standard form means specifically that terms are written in order from greatest to least degree. Terms are written in order from greatest to least degree. So we're looking at those exponents specifically, and we learned how to decide what degree each monomial is. So we're looking at each monomial contained in this polynomial, and we're saying what is its degree, and we're going to put the greatest degrees on the left on down to the least degrees on the right. So example, this is written in standard form. 3x to the third, a third degree polynomial, plus 5x squared, a second degree monomial, plus 7x, a first degree monomial, plus 1, a 0 degree monomial. And this polynomial is now written in standard form. If this would be over here, if any of these would be changed in positions, it would not be in standard form. But notice we've got a third degree, second degree, first degree, and 0 degree monomials that form this polynomial. Okay, so number 5 is the degree of a polynomial. We're going to say the greatest degree of any term or monomial term in the polynomial. Okay, the greatest degree of any term in the polynomial. So we're looking at this. This has the greatest degree. Nicely, it's written in standard form. So anything that's written in standard form, this first term here defines the degree of the polynomial. Okay, so an example. This same thing that we wrote down before here. If I'm asking you what is the degree of this polynomial right here, the only thing you need to look at is the degree of this monomial at the beginning. And so we can say that this is a degree 3 polynomial, okay? This is degree 3 polynomial because its highest termed degree is 3, okay? We don't add them together. We just look at its highest degree. Okay, and finally, leading coefficient. You should kind of know what this is, but it is the coefficient of the first term when written in standard form. Coefficient of the first term when written in standard form. So again, let's write down this same example here. Its leading coefficient is 3. Its leading coefficient is 3. It is this guy. Okay, so these are a bunch of terms that I want you to know at this point. They're going to be coming up and again and again and again over the next 3 or 4 weeks. And so this is just a good guide for when these do come up, when you are asked about them, you can just go back to these first couple pages of the Flipbook and find out what they mean and remember what they mean. Okay, so this is it for the definitions portion of this Flipbook. I'm going to pause this or stop this and then make a new video that you should turn to now on standard form and classifying polynomials.